Good evening, children. The first chapter in your maths book is numbers. So today, let us fastly recall the numbers and its different types. So, what are the different kinds of numbers available? The first and the foremost type of number is the natural number. So, what are natural numbers? Natural numbers are nothing but counting numbers. Consider if there are a pile of books and if I ask you to count the number of books. So what you'll be doing, you'll be either starting to count from the top to bottom or from bottom to top. Whatever it is, you will be starting to count from 1. Am I correct? So 1, 2, 3, 4, 5, you will be counting like this. You won't start from 10 and you won't start from 15. You will start from 1. Isn't it or not? So natural numbers are nothing but counting numbers. So natural numbers are nothing but counting numbers. Natural numbers starts with 1. It is generally denoted as n. N stands for natural number. Natural numbers 1, 2. It starts from 1, 2, 3, 4, etc. So these 3 dots denotes that there is no end. It goes on. There is no end in one side. It goes on. But the starting point is 1. So 1, it starts from 1. It does not end. If you see this in the number line, you know what is the meaning of the word number line? So if you mark these things in the number line, 1 will be here, 2 will be here, 3 will be here, 4, 5, 6, 7. You can very easily see in the number line I have marked a ray symbol. This arrow symbol stands for a ray. What is a ray? Ray has a starting point. It does not have an ending point. As you can easily visualize that it starts from here. It starts from 1. It does not end anywhere. Isn't it? So these are natural numbers. So what are natural numbers? Natural numbers are nothing but counting numbers. It starts from 1, it goes on. There is no end, right? The second type of number is the whole number. Consider, I have 100 rupees with me. I am just going for a shopping, right? I have spent all the 100 rupees which I have. Now, how much do I have? I do not have any amount with me. Yes or no? I had 100 rupees, I spent all the amount, now I don't have any amount with me. So, in order to denote that emptiness, what is that? Emptiness. I don't have any money with me. So, this emptiness has to be denoted by a number. So, in order to denote that emptiness, we need a symbol. We need a symbol to mention. That's why we got 0. A mathematician found the 0 which does not have any value. 0 does not have any value when it is written alone. So whole number, generally we denote whole number by W. Whole number starts from 0, the next number is 1, 2, 3, 4, etc. The same thing, this etc. These 3 dots stands for, it does not end, it goes on one side, right? We can even denote this in the number line. Here the starting number is 1, that is a 0. So as I told you, that is 0 is included along with the natural numbers. This we define as whole number. The first one is 0, 1, 2, 3, 4, 5, 6, 7. As you can see, I have marked the ray here also. So what does it mean? As natural number also does not have an end point in one side. But the starting is so clear, it starts with 0. So natural number is finished, whole number is finished. Then the next type of numbers is the integers. So what are integers? Including the negative numbers along with the whole number, we get integers. Right. Let us take like this. Etc. minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So these are integers. What do you understand from this? You can see 3 dots here and 3 dots here. In the sense, there is no end on both the sides. There is no end on the negative side and there is no end on the positive side. And 0 is at the center of the integer. That is, in the right hand side of 0, in the right hand side of 0, you have got positive integer. In the left hand side of 0, you have got negative integers. We can even denote this in the number line. Here, can you put the symbol like this? No, you should not put the symbol like this. You must put arrows on both the sides. So what you can do, you can put 0 in between, arrange the positive numbers here and arrange the negative numbers here. I have arranged the positive numbers in the right hand side and I have arranged the negative numbers in the left hand side. As you know very well that in the number line, the numbers are arranged in the ascending order. Isn't it or not? Not in the descending order, it is arranged in the ascending order from left to right. In the sense, you know that 1 is definitely greater than 0, and 2 is definitely greater than 1, and 3 is definitely greater than 2, and 4 is definitely greater than 3. In the same way, minus 1 is greater than minus 2, minus 2 is greater than minus 3, and minus 3 is greater than minus 4. The same way, as we can see, when you proceed, even in the negative numbers, if you proceed from left to right, the value of the number gets increased, it does not get decreased. In negative values, if the number is big, the value is small. If the number is small, then the value is big. Clear with the idea? So these are integers. So we have seen these three things. The first one is natural number, the second is whole number, the third one is what? Integers. The next type what we are going to see is the rational number. And integers, see, we denote the natural numbers by n, and we denote the whole numbers by w, and we denote the integers by z, right? The next one is rational numbers. So what are rational numbers? See, you have got a number 0 here, and you have got another number 1 here. Is there any numbers between this 0 and 1? Yes, definitely we have got a number. Say for an example, I will take a number 1 by 2. So what is the value of this 1 by 2? If you divide this 1 by 2, you will be getting what? You will put a 0 and you will put a 0 point here. 5 times you will be getting 10, the remainder is 0. So you will get 0.5. You know very well that 0.5 is definitely greater than 0, but it is less than 1. So there are numbers between this 0 and 1. In the same way, there are numbers between this 1 and 2. There are numbers between this 2 and 3. And there are numbers between this, numbers between this, numbers between this. So you have got always, in mathematics, you always get a number between any two numbers, right? So there are uncountable numbers in between two numbers. Those numbers are called as rational numbers. To say it in simple, a rational number is of the form a by b. A rational number is of the form, a by b, where a and b are integers. You can apply any integer here in the place of a and in the place of b. If you apply any integers in these places, you will be getting a fraction, isn't it or not? So that kind of fraction is considered as rational numbers. Say for example, you can apply minus 5 by 3 or 2 by 4 or minus 6 by 9, any kind of numbers. Here you have got negative number and here you have got positive number. There is no problem in it, because a and b are integers. They are not natural numbers, they are not whole numbers, they are integers. So you can even take up the negative values. So rational numbers, the general form of the rational number is a by b, where a and b are integers. Any doubt in this? There are two main types of rational numbers. Let me explain this one by one. The first one is terminating decimal. The second one is non-terminating but repeating decimal. So what these two are? Let me explain these two with an example. Take this terminating decimal. I am going to divide 10 by 2. My answer will be 5. Isn't it or not? And if I am going to divide 5 by 2, the answer is going to be 2.5. If I am going to divide 2.5 by 2, the answer is going to be 1.25. Isn't it or not? 1.25. So you can see in all these three cases, if you divide 10 by 2, you are getting a complete answer. And if you are dividing 5 by 2, you are getting a complete answer. If you are dividing this by 2, you are getting a complete answer. The answer gets over, it gets terminated. So such kind of decimals are called as terminating decimal. The next one is non-terminating but repeating. So what it is? Let us take a number 10 by 3. If you divide this 10 by 3, what answer you will be getting? You will be getting 3.33333, etc. So what do you mean by this etc? These 3 dots, this stands for what? It does not end, it goes on. So how long it goes? There is no end for it, right? So 3.333333 etc. It goes on like this. It need not be the same number, it has to be repeated again and again. It can also be like this, 5.343434. It can also be like this. Here 2 numbers are getting repeated. Likewise 3 numbers can be repeated, 4 numbers can be repeated, 10 numbers can be repeated. It is not necessary that there should be only one number getting repeated. There can be a group of numbers getting repeated again and again. Okay, see, you can see here the decimal gets terminated. Terminated means it gets end. Here the decimal gets end. Here the decimal does not get end, but it gets repeated. So that's why this is non-terminating but repeating. So both these falls under the category rational numbers. Clear with the idea? So generally rational numbers are denoted using the letter Q, right? So what have we seen? The first one we have seen what are natural numbers, the next one we have seen what are whole numbers, the third one we have seen what are integers, then the fourth one we have seen what are rational numbers and its 2 types, right? Now let's see an example related to this concept. Write the decimal forms of the following rational numbers. Right, just a minute. See, write the decimal forms of the following rational numbers. The number given is 1/4. So as you can see, 1/4 is in the form of p/q. It is in the form of p/q, where p and q are integers. You can see 1 and 4, both these numbers are integers. You are asked to convert this in the form of rational. That is, you are asked to convert this in the form of decimal. So how will you convert this in the form of decimal? Just divide this 1/4. 1 should be divided by 4. You can add a 0 here and you can keep a decimal over here, isn't it or not? Is it possible to divide? Yes. How many times? 2 times 8, remainder is 2, 0, 5 times. The answer is 0.25. See, you can clearly see that the rational numbers has been converted in the form of decimal. Here you can mention it as 0.25, or else without even dividing you can do this. Take this number once again, 1/4 is equal to, I need to know the answer. What can I do? I can make this denominator as 100. How? By multiplying this with 25. Even I can multiply the numerator with 25. So what it will become? 1 into 25 will be 25, 4 into 25 will be 100. So 25 by 100, it gets, see the decimal is at last place. If you divide by 100, it gets 2 steps back. So the answer is 0.25. Whatever the step may be, but the concept is same. So you are asked to convert this rational number into decimal number, right? The next number is 1/3/20. 1/3/20. As you can see, this is not a normal fraction, this is a mixed fraction. So first what you have to do, you have to convert it in the form of improper fraction and then do the sum, or you can even just keep this 1 as it is and divide the 3/20. So you can divide this 3/20. Is it possible to divide? No. So what you can do, you can put a 0 and you can put a point here. So 1 times it is possible, 20, the remainder will be 10, isn't it or not? So one more time you can add the 0. So 20 into 5 will be 100, the remainder is 0. The answer for 1/3/20 will be 1 point. See, you have got 1 here, that is plus 0.15. You need to add this with this value, which is equal to 1.15. Clear? The next number is going to be minus 5, 4/5. You keep this minus 5 as it is. As you can see that this is a mixed fraction, isn't it or not? So you can convert it into the form of improper fraction. Multiply this 5 into 5. 5 5s are 25. You need to multiply these two numbers and with the result you need to add this. 5 5s are 25. 25 plus 4 will be what? 29/5. So now we can divide this 29 by 5. So 5 5s are 25, remainder is 4. We can put a 0 and keep a dot. 5 8s are 40, the remainder is 0. So what is the result? You need to put this minus as it is 5.8. So this is converting a rational form into decimal form. The next sum is 1 by 3. It's 1 by 3. So 1 I am going to divide by 3. It's not possible. Put a 0 and keep a dot. So 3 3s are 9. Once again you can put 1 0 3 times 9. Once again you can put 0 3 times. It goes on like this, isn't it or not? This I have mentioned earlier. This is what? This is non-terminating, non-repeating. Does not get n, and at the same time it does not. It gets repeated, right? So 1 by 3 equal to 0.333 etc. This we use to denote as 0.3 bar. So with this we close our today's session, and I'll be adding up the homework along with this video. So I want you all to complete the homework. See you back in the next class.